So we have our data set formatted and we're ready to calculate correlations. But first I want us to label what each type of variable is. So this one is categorical, and to be more specific, you could call it binary, which means two categories. I mentioned that we need all of our categorical variables to be binary, which means a 1 and a 2 are the two possible values. So all of these are binary. Then grade level is actually categorical, but it's a different type of categorical variable. The categories have a ranking to them. So when the categories have a ranking from lowest to highest, it's called an ordinal variable, which is a type of categorical variable. But for the purposes of our project, we're just going to treat it like it's quantitative or numerical. And here, procrastination, we're also going to treat that as being quantitative, even though it's actually another ordinal variable. And GPA is obviously quantitative because you're dealing with quantities of GPA. And now we're going to pick two variables and calculate a correlation between them. And we have two options. We can either pick a categorical and a quantitative variable, such as, well, an example would be housing situation and GPA. Or we can pick two quantitative variables, such as procrastination and GPA. But what we can't do is pick two categorical variables like housing situation and psychology. There's actually a different statistic you would need if you wanted to calculate that correlation. And it's you would need to create something called a contingency table, which you might have heard of before in a statistics class. It's where you have a 2 by 2 table, and you have housing situation, yes, no, psychology, yes, no, and you can calculate a special type of correlation coefficient for that situation for two categorical variables, but we're not covering that correlation in our class. So I'm just going to ask you to not pick two categorical variables and just to go with these two options. So let's calculate the correlation between housing situation and GPA. And that's okay for us to do that. It's okay for us to correlate those because it's one of our options. It's categorical and quantitative. So what we need to do is type in equals CORREL for correlation, put a left parentheses, highlight the housing situation data. It goes from G2 to colon G7, which just means it goes from column G row 2 to column G row 7. We put a comma, and then we highlight the GPA column, which is variable 2. And now we put a right parentheses and press enter, and we will get the correlation. And another way to enter this, other than highlighting the values, is to just type out G2 colon G7 and then type out N2 colon N7. So if you know what the range of values is, you could just type it out rather than highlighting the numbers if you wanted to do it that way. Now we'll press enter and we'll get the correlation. And it is a 0.84. And in just a few minutes, I'll explain to you what that means, how to interpret that. Now let's calculate the correlation between procrastination and GPA, which is going with option 2. We're pairing two quantitative variables. So equals CORREL, left parentheses. Procrastination is variable 1, comma, GPA is variable 2. then put the right parentheses and press enter. And this one is a negative 0.72. And for your study, I want you to calculate a minimum of 5 correlations. So far, in my example, I have 2, but for your project, I would want you to have at least 5, which would be 3 more than this. And to take those 5 correlations and put those into your result section, and then discuss the findings in your discussion section at the end of the paper. But I'm not going to calculate 5 correlations right now because I just want to move ahead and explain how to interpret these correlations. Right now, I'm going to take the 2 correlations that I just calculated and show you what they would look like in a scatter plot, or show you what they would look like at least roughly. I just want to show you the overall trend that you would see in the scatter plot. So we had a positive correlation between housing situation and GPA. It turned out to be a 0.84. So if the correlation is positive, that means that the line rises from left to right across the x-axis. So it rises like this. It has a positive slope. What this is telling us is that on average, the people who have a housing situation of a 1 are lower in GPA. They're further down on the y-axis. And on average, the people who have a housing situation of 2 have higher GPAs. They're higher on the y-axis. And the line that's connecting, the line that's showing the trend is rising from left to right because it's connecting these dots down here. Well, it's connecting the average for 1, which is down here, with the average of 2, which is up here. So this average is lower, this average is higher, and since it's connecting them, it rises. Technically, the regression line isn't connecting the 2 means, but what I just told you is correct just conceptually, but statistically, that's actually not correct. So when you interpret this, what you would say is, on average, people with a housing situation of 1 are lower in GPA, and people with a housing situation of 2 are higher in GPA. And in order for us to make sense of that, we have to remember what a 1 stood for and what a 2 stood for. So I believe I coded a 1 as on campus and a 2 as off campus. And if that's the case, then that would mean that people who live on campus are lower on average, and people who live on campus are higher on average. So I mentioned that when you have a variable that's coded with a 1 and 2, you have to remember what 1 stands for and what 2 stands for to make sense out of the correlation. Now, let's look at this other one. It's a negative 0.73, and it's a negative correlation, which means that the line has a negative slope. So this is called the regression line. You might have learned about this before in a stats class. It's the line that shows the trend in a scatter plot, and if it goes up when the correlation is positive, and it goes down when the correlation is negative. So what this negative correlation is telling us is that on average, the people at the left end of the scatter plot are higher in GPA, and the people toward the right end of the scatter plot are lower in GPA, which means as we go further to the right, the dots get lower and lower, at least on average. So this is telling us that overall, the people who are low in procrastination tend to have higher GPAs. They tend to be up here, and the people who are procrastinating a lot tend to have lower GPAs down here, or somewhere lower compared to the people up here. and when you follow the trend, it goes downward. So you can kind of think of it as well, you can kind of think of it as as 5 different averages. So the average of 1, the average GPA of 1, the average of 2, the average of 3, 4, and 5. And you could think of the line as connecting those 5 averages and it going downward as it connects them. Statistically, that's not actually correct, but that's just conceptually, that is what's happening. So the way we would interpret this is we would say, overall, people who are procrastinating more tend to be lower in GPA. Remember that if a correlation is negative, it means when one variable is higher, the other variable tends to be lower. They tend to go in opposite directions. And in this case, what we've just discovered is that when GPA is higher, when procrastination is higher, GPA tends to be lower, at least within our group of participants. So that's how you'll interpret your correlations. If you're unsure of how to interpret it, I recommend making a scatter plot just maybe on paper, like I did here. So if let's say you're wondering, let's say you've calculated the correlation between gender and hours on social media, and you get a positive correlation. It might be a good idea to make a scatter plot like I did and put a 1 and a 2 here, and put hours on social media on your y-axis. And if it's a positive correlation, make the line rise like I did. If it's a negative correlation, have it go downward, and then look at your scatter plot and make sense out of it or reach a conclusion about it. But like I said, you have to remember what 1 stands for and what 2 stands for. Or if you found a correlation between something like hours on social media and hours of sleep, you could make a scatter plot like I did here. And if the line goes up, if it's a positive correlation, draw a line going upward. If it's a negative correlation, draw a line going downward, and then make sense out of it by looking at your graph. So if you're kind of a visual person, that might help you interpret the correlation. And that's really all I needed to cover in this video. In the other video I recorded, I show you how to take the correlations and test them for statistical significance in a p-value calculator, which is available online, and then write up the correlations in a results section. So make sure to refer back to that video for writing your results section.